All right, guys, welcome back. We're going to jump into our exercises now. So we'll go through this fairly quickly because we have quite a few exercise problems and I want us to get to as many as possible. Let's take a look here at number 1. We have identify the exponent and the base in the expression 6 to the 12th power. So we have a repeated factor and the number that tells us how many times it repeats. So the big number is raised with a smaller number, right? Our superscript here. So the base is 6, and the exponent, is our term here, is 12. All right, so the exponent is 12 and the base is 6. We say this 6 to the 12th power, which means 6 times 6 times 6 times 6 times 6 times 6. 6 times. All right, problem number 2. We have describe the steps you would take to evaluate the expression n to the 5th power when n is equal to 3. Then evaluate the expression. So the question is, what should we do first and what should we do next? All right, so we want to substitute 3 for n. We'll write 3 to the 5th power. And that is written out as 3 times 3 times 3 times 3 times 3. If we multiply those together, we get 243. Now tell students, go ahead and multiply 2 at a time. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 20, 40, 60. 7 for 21 will be 60 plus 81 will be 81. And 8, 16, 24 plus 1, 2, 3 gets us to 243. So you can check those off as you go. Makes it a little simpler. All right, so we substitute 3 for n and rewrite that as 3 to the 5th power and expand to 5 3s, and we multiply to get 243. Now let's take a look at problem number 3. 15x when x is equal to 4. We're just going to multiply that 15 times 4. That will land us at 60. 15, 30, 45, 60. Problem 4 will take us to a decimal point. 0.4r when r is equal to 6. So again, we just substitute in our 6 and we'll multiply 0.4 times 6. Now in this one, we want to be sure to write that decimal place over once to the left. We'll shift that decimal place over. So 6, 12, 18, 24, yes, and then shift that over to the left. Very important with our decimal places that we're shifting there. So our answer is 2.4. Let's take a look at number 5. W minus 8 when W is equal to 20. So again, we just plug in that 20 for W. 20 minus 8 gets us to 12. Number 6, 1.6 minus G when G is equal to 1.2. We're practicing with decimals here. So line those decimals up. 1.6 minus 1.2. Line those decimals up, bring the decimal down, and that gets us to 0.4. 7, 5 plus m when m is equal to 7. Let's substitute 5 plus 7. That gets us to 12. Let's try number 8. All right, so number 8 says 0.8 plus h is when h is equal to 3.7. So let's add those decimals carefully as we substitute 0.8 plus 3.7. Eight plus 7 is 15. Write down our 5, bring up our 1. As we are carrying over, bring down our decimal place, and then bring that 1 down. 1 plus 3 is 4. 4.5. Okay, number 9, 24 divided by f. We're at divided by. 24 divided by f, or 24 over f, when f is equal to 8. So let's just substitute that in. That would be 24 divided by 8, which gets us to 3. 10, t over 5 when t is equal to 4.5. So let's substitute and divide. What is 4.5 divided by 5? Put a 0 there, will not go in. We'll move on over to 45 now. 5 into 45, 5 times 9, to get us to 0.9. 11, 2.5m when m is equal to 4. So let's multiply 2.5 times 4 when the variable is next to the integer with no operation holding them in between. It is multiplication. So we'll multiply 2.5 times 4. 4 times 5 is 20. We'll carry over again. 4 times 2 is 8 plus 2 is 10, and make sure we put that decimal place straight down to get to 10. All right, problem 12. 1/2 k when k is equal to 2/3. Here we'll continue practicing, but we're multiplying fractions. So let's multiply those fractions. 1 over 2 times 2 over 3. We can multiply straight across. 1 times 2 is 2. 2 times 3 is 6. 2 over 6. Now this can reduce. We can divide both 2 and 6 by our greatest common factor here, which will be 2. 2 divided by 2 and 6 divided by 2 will get us to 1 over 3, or 1/3. 13, y minus 1/2 when y is equal to 5/6. So let's use a common denominator here. Six is our common denominator. We're subtracting. Both 6 and 2 will go into 6, so this will be our common denominator. Okay, our least common denominator is 6, so what is 1/2 and 6th? That's 3/6, right? 2 times 3 is 6. 1 times 3 is 3. And then 6 times 1 is 6. 5 times 1 is 5. We don't need to change that one, because 6 was already our denominator. Now we can take 3 away from 5 to get to 432 2/6, which again reduces down like we did before to 1/3. When we divide out both by 2, we get 1/3. 14, h plus 1/3 when h is equal to 1 1/3. So we are adding 1/3 to 1 1/3. Let's go ahead and add 1/3 plus 1/3 first. This will get us to, whoops, let me write that better. This will get us to 2/3. Now we can combine that with our whole number, which is 1, to get us to 1 2/3. All right, so we're in our next section. What is the value of 2.5m when m is equal to 10? This will be a multiple choice, like we'll find on our standardized exams. So let's ignore the answer choices for a moment here and solve first. What's 2.5 times 10? Here we can write that 0 out because we're just adding a 0 when we multiply anything by 10. 1 times 5, 1 times 2. But let's make sure that we go over the correct amount of hops to the left. So here it's 1 hop to the left, 1 hop to the left. We'll put our decimal place there and rewrite this as 25. Choice D is 25. D is correct. All right, our next section tells us to write the power in words and as a product. So we'll start with 16 here, 12 to the 5th power. So let's name the base and the exponent, then expand that repeated multiplication. 12 to the 5th power. Okay. We can write that out. 12 to the 5th power. Now we count the 5 factors allowed. Let's go ahead and write those down as we go. 12 times 12 times 12 times 12 times 12. 1, 2, 3, 4, 5. 12 to the 5th power. 17. 7 to the 3rd power. 7 times 7 times 7. 18. 3.2 squared, or 3.2 to the 2nd power. 3.2 squared. We can say it either way. Now the base is 3.2 is what's important, not just 3. So we are raising the decimal place here to the 2nd power, or squaring it. All right, so 3.2 to the 2nd power. Or 3.2 squared. And we write that out as 3.2 times 3.2. Twice there. 19. 0.3 to the 4th power. We need 4 of those 0.3s. 0.3 is our base. That's our decimal in this case as well. So 0.3 to the 4th power, sorry. So we're not going to say squared or cubed, but to the 4th power. Okay, now we're going to write that out. 0.3 times itself 4 times. 0.3, 0.3, 0.3, 0.3. And you can count those in class if you like to, just to make sure if you're doing a problem like this. 1, 2, 3, 4. All right, great. Check. We also can apply the same rule to fractions. So 1/2 to the 8th power. All right, 1/2 to the 8th power. Write down 8 and add an h there for 8th. And this is 1/2 times itself 8 times. 1/2, 1/2, 1/2, 1/2. That's 1, 2, 3, 4. 5, 6, 7, and 8. And we can count those just to make sure. 1, 2, 3, 4, 5, 6, 7, and 8. Check. Now we have a variable. We're in algebra, right? We're working with variables. Problem 21 is n to the 7th power. We just write it like we see it. N to the 7th power, and that's 7 times. 1, 2, 3, 4, 5, 6, 7. 7 times that n is multiplying itself by. 22, same idea, y to the 6th power. Check, and that will be 6 times that y is multiplying itself by. Y times y times y times y times y times y. Y to the 6th power. Same idea with our t. t to the fourth power. Check. 1, 2, 3, 4. T times t times t times t. Check. All right, let's take a look at 24. Describe and correct the error in evaluating the power. So the error is treating the exponent as a multiplier instead of a repeated multiplication instruction here, right? So what does squared actually mean here? Multiply 0.4 by itself. 0.4 times 0.4. Now this will get us to 0.16. We multiply that 4 by 4 to get to 16. Let's remember to move that decimal place over 1, 2, twice. 1, 2, to get to 0.16. So not 0.8, but 0.16. Let's take a look at 25. 5 to the fourth power, what's going on here? The base is 5, not 4. So the exponent is only going to tell us how many times the base repeats itself in multiplication. So here we'll have 5 times 5 times 5 times 5, 4 times, right? 5 times 5 times 5 times 5. And it's easy if you just cross them out as you go and do 2 at a time. 5 times 5 is 25, for example. 25 times 5 is 125. And then 125 times 5 gets us to 625. So not 1024, but 625. All right, let's evaluate our powers. We'll begin with 26. This is 3 squared, so we expand and multiply. 3 times 3, which gets us to 9. 10 squared, or 10 to the second power, is 10 times 10. Our base is 10. 2 is our exponent. 10 times 10 is 100. 28, 1 to the fifth power, 1 to any power, will always be itself. No matter how many times you multiply 1 by, you'll always arrive at 1. But this does mean 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5. 29, 11 cubed, or 11 to the third power. Now this is our base of 11 multiplying itself 3 times. So 11 times 11 times 11. Now 11 times 11 is 121. And now we want to check to make sure that 121 times 11 is 1331. Instead of multiplying this out standard algorithm-wise, I'll just check on my calculator really fast. 11 times 11 is 121, and 121 times 11 is 1331. That is correct. All right, 5 cubed is 5 times 5 times 5. 5 times 5 is 25 times 5 is 125. 3 to the fifth power, that would be 3 times itself 5 times. 1, 2, 3, 4, 5. Now let's check it. 3 times 3 is 9. Times 3 is 27. Times 3 is 20, 40, 60. 7, 14, 21. That would be 81. Times 3, 8, 16, 24. 24 plus 3. Or 240, sorry. 240 plus 3. Will be 243. Yes, that will check out. 243. 2 to the sixth power. 2 times 2 times 2 times 2 times 2 times 2. 6 times, right? 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. This is why it is helpful to cross those out as you go and just to multiply 2 at a time. 64 is correct. All right, let's skip over to our fraction now. 1/4 squared, or 1/4 to the second power here for problem 34. Let's practice multiplying our fractions out. 1/4 times 1/4 gets us to 1. 4 times 4 is 16, 1/16. Okay, what about 35? 3/5 to the third power, or 3/5 cubed. 3/5 times 3/5 times 3/5. All right, excellent. 3 times 3 times 3. Let's multiply those first. 3 times 3 is 9, times 3 is 27. Okay. And then 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. 27 over 125. 27 1/25 is correct. Same for 36. We'll multiply that fraction by itself 4 times. 2/3 times 2/3 times 2/3 times 2/3. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 times 3 is 9, times 3 is 27, times 3 is 81. 16 over 81 is correct. And our last problem in this set, 37, 1/6 to the third power, 1/6 cubed. 1/6 times 1/6 times 1/6. Now 1 is going to be the answer here no matter how many times you multiply 1 by. It will always be 1, but now we want to check is 6 to the third power indeed 216. 6 times 6 is 36. And then 36 times 6, let's check it. 6 times 6 is 36. 6, 12, 18 for 6 times 3. 18 plus 3 is 21. 216. Correct. 1 over 216 or 1/216. Let's continue on. We're going to evaluate our expressions now. All right, so 38 is x squared when x is equal to 3/4. So let's plug in, substitute the fraction, then square it. So 3 squared over 4 squared. Three times 3 is 9. 4 times 4 is 16. 9/16. P squared when p is equal to 1.1. So you may notice this is like squaring 11. 11 times 11, and then moving that decimal place over. 1.1 times 1.1 is like 11 times 11, except we want to be sure to move that decimal place over twice. 1, 2, 1, 2 to get to 1.21. Let's bring in two variables, x plus y. When x is equal to 11 and y is equal to 6.4. All right, let's plug those in. 11 plus 6.4. If we line them up, might be a little easier. 6.4, okay. Bring down our 4, bring down our decimal place. 11 plus 6 is 17. 17.4 checks out. 41, kn. Now when the variables are next to each other with no operation in between them, that is understood to be multiplication. So this is k times n. So we'll substitute in our integers and multiply here. So this will be 9 times 4.5. 4.5 times 9. 9 times 5 is 45. 9, 18, 27, 36 plus 4 is 40. Make sure we bring our decimal place over once to get to 40.5. That is correct. 42, w minus z when w is 9.5 and z is equal to 2.8. Let's substitute those in and subtract. We're practicing subtracting decimals now. 9.5 minus 2.8. 9.5 minus 2.8. All right, we need to borrow. So let's go ahead and borrow here. We're going to borrow a 10. That becomes 15, and this becomes 8. 15 minus 8 is 7. Bring down our decimal. And 8 minus 2 is, 8 minus 2 is 6. 6.7 is correct. 43. B divided by C or B over C when B is equal to 24 and C is equal to 2.5. All right, when B is equal to 24 and C is equal to 2.5, B over C here. Let's go ahead and plug those in. 24 divided by 2.5. Let's practice that skill. Here we want to bring our decimal place over once and also here. What we do on the outside, we want to do on the inside. What we do to our divisor, we do to our dividend. Now we're ready to see how many times 25 will go into 240, because it will not go into 24. So 24 being just one below, 25 is a good indicator that will be just one below 10, right? Because 25 times 10 would be 250. So 25 times 9. What is that going to be? Well, 250 minus 25 will get us to 225. 240 minus 225. Let's go ahead and borrow a 10. That will take us to 5 and 1. 25 will not go into 15, but it will go into 150, so go ahead and add our decimal place here. 25 times 6, or 6 quarters, would be $1.50, right? 25 times 6, 9.6 is correct. Now we're on a multiple choice question for 44. Which expression has the greatest value when x is equal to 10 and y is equal to 0.5? And here are the choices. All right, so x equals 10, y equals 0.5. We don't need to guess. We can evaluate each choice and compare. So, for example, x times y, 10 times 0.5 will get us to 5. Just bring that decimal place over once. What about x minus y? This will be 10 minus 0.5. Which gets us to 9.5. Just go down half of 1 there, 1/2, to go from 10 to 9.5. C, x divided by y. What does that get us to? 10 divided by 0.5. We need to bring this decimal place over to the right once, which means we also need to do the same thing to our dividend. All right, how many times does 5 go into 100? 20 times 5, right? 20 times 5. Okay, so 20 so far has our greatest value. So let's X out of these and compare 20 to D. D will be y divided by x. 0.5 divided by 10 this time. Switch it around a little bit. 0.5 divided by 10. Okay, 10 will not go into 5 evenly, right? So let's go ahead and put a 0.0 there as well. And then bring down a 0. 10 will go into 50. 5 times, that's 0.05. That's a much lower number, right? 5 100ths there, or 1/20th. But we're looking for the greatest value. So C will be our correct answer. All right, let's take a look at 45. This is another multiple choice question. Let B be the number of tokens you bought at an arcade and let U be the number you have used. Which expression represents the number of tokens remaining? All right, so remaining means start amount minus amount used. Now we're looking for an operation that would match the words remaining after using some tokens, which will be subtraction. And then we'll connect the context to the operation. This is total bought minus total used. Which, by the way, we only have one subtraction anyways, helping us to eliminate wrong answer choices quite quickly there. And just to check to make sure it's correct, we can bring in that context. Total bought minus total used, or B minus U. Okay, what about 46? Let x and y be whole numbers greater than 0, with y greater than x. Which has the greater value? 3 to the x power or 3 to the y power? And explain. This is comparing powers, right? All right, so when the base is the same and greater than 1, the expression with the larger exponent will be greater. So which exponent is larger here? Y is larger than x. So let's state those rules in words. Same base bigger than 1 plus larger exponent means larger value. So 3 to the y power is greater. And our last problem here for the set, before we move on to problem solving, which will be in our next video, will be number 47. This is our challenge problem. For which whole number value or values of x greater than 0 is the value of x squared greater than the value of 2 to the x power? Explain. So this is easier if we make a comparison table instead of just guessing. So what happens when we compare x equals 1, 2, 3, 4, 5? Let's start there. So we have our two columns, right? We'll have x squared and 2 to the x power. Now these will be much easier to compare. All right, so at x equals 1, 1 is less than 2. At x equals 2, 4 equals 4. At x equals 3, 9 is greater than 8. At x equals 4, 16 equals 16. At x equals 5, 25 is less than 32. Let's check that. One is less than 2. 2 squared, 4, is equal to 2 to the second power 4. What about for 3? 3 squared is 9. 2 to the third power will be 2 times 2 is 4 times 2 is 8. Oh, now it's greater than. 4 times 4 is 16. 2 to the fourth power, 2 times 2 is 4 times 2 is 8 times 2 is 16. These are equal. And then for 5, 5 squared is 25. And 2 to the fifth power, 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So back to less than. All right, so x equals 3 is the only whole number greater than 0 that would work. Let's highlight that. So x equals 3 only. And we can confirm in our answers that this is correct. All right, join us for our second video. We'll be covering the next part of our exercise set. I know it's quite a few problems, but I want to make sure that we're getting plenty of practice before we jump into the next section here in Chapter 1. For our full Algebra 1 course, we'll see you soon.